This video goes over how to find the maximum and minimum of a parabola. Max and min is an important application in any type of projectile motion, rocket ships, missiles, catapults, and also in finance. Finding your maximum profit value is obviously an optimal choice. So let's look at these two parabolas, and we're going to find the maximum or minimum value and when it occurs. A maximum is when you have a parabola opening down. Minimum is when you have a parabola opening up. So the first thing that we're going to do is complete the square by factoring out the 3 from the first two terms. And then I'm going to take my b value, divide by 2, and square it. So I've got 8 divided by 2 and squared, which is going to be 16, which is going to give me the value that I need to complete my perfect square. So I'm going to take my first 3 terms and factor my perfect square. I'm going to remember to multiply what I factored out by my last term. And then combine my constants together to get my k value at the end of my parabola. So what I need to decide is if it's a maximum or a minimum. In this case, my parabola opens up because my a value is positive. So that means I'm going to have a minimum value. And my minimum value is just equal to my y value of the vertex, or my k value. And my minimum value occurs at x equals 4. My next parabola, I'm going to do the same thing. You should notice that we've got a negative sign here. So you should be expecting a maximum at the end, which is important in revenue modeling. So we're going to factor out our minus 2. We've got x squared plus 5x minus 9. I'm going to identify my b value, divide by 2, and square. Which is going to give me 10 over 4, which I can then add 10 over 4 and subtract 10 over 4 to get my perfect square. And now I'm going to factor my first 3 terms as a perfect square, so x plus 5 over 2 all squared. And then I'm going to remember to multiply my last term by whatever I factored out. So I'm going to end up with plus 20 over 4, which is just 5. And then I can combine those constant terms to get my final equation of a parabola in vertex form. And now I can investigate whether I have a maximum or a minimum. Because my parabola opens down, my a value is negative. I'm going to have a maximum value. And my maximum value is minus 4, which is just my k value at the end. And this is going to occur at the x value of my vertex, which is minus 5 over 2. So let's take a look at some examples where you might see in a word problem or in the real world. And so here we're trying to find two numbers whose sum is 14 and whose product is a maximum. So I'm going to let x represent one number and let y represent the other number. So now I'm going to write my first equation. So two numbers whose sum is 14. So that means x plus y has to equal 14. Now my next equation is going to be for a product. So p is equal to x times y, and I know that it's going to have to be a maximum. So what if I can write that equation so that it's all in terms of one variable, so that it is a parabola, and then I can find the vertex. So let's rearrange our sum equation for x. And now I'm going to substitute that expression, just like we did in our first unit, into our product equation. Now I'm going to sub x equals 14 minus y into my equation that I have for the product. So I've got p equals 14 minus y times y, and then I'm going to expand that so that I have an equation of a parabola in standard form, and I'll move the y squared to the beginning here. So now I've got a model of what that situation looks like. I know I'm looking for the maximum, so that must mean that I have to find the vertex. So I'm going to complete the square, factor out my number, in this case, -1, that's in front of the y squared of my first two terms. Now I'm going to identify my b value just like I did before, divide it in half and square it. 14 divided by 2 is going to be 49. So now I can rewrite my equation as y squared minus 14y plus 49 minus 49. So now my first three terms I can factor as a perfect square. So y minus 7 all squared. And then I'm going to remember to multiply whatever I factored out by my last term plus 49. And now this is going to tell me my vertex. So my vertex of this parabola is 7 and 49. So my y value, or my variable here, this is going to be the product. This is going to be the y value that gives that product. So if y is equal to 7, x must be equal to 7 as well. And because of the way that we've modeled the situation, we can say with confidence that those two give the greatest product when they add to 14, and their product is a maximum. So let's look at another example with fencing. Here we've got a rectangular lot is bordered on one side by a stream, and on the other three sides by 600 meters of fencing. Find the dimensions of the lot if its area is a maximum. So again, you're looking for vertex. So let's let x represent the width of the lot. X. And we'll let y represent the length of the lot. So now I'm going to set up two equations to demonstrate the situation. So my first one is really a perimeter equation. I've got 600 meters of fencing, and I know that I've got three sides that add up to that, 2x plus y. My other equation that I know is the area. My area is going to be length times width, which in this case is y times x. So now I'm going to do the same thing that I did in the number problem above, is I'm going to rearrange this equation, and I'm going to rearrange for y, because I think that's going to be a little bit easier. So y equals 600 minus 2x. Now I'm going to sub that expression for y into my area equation. What I'm trying to do is create a model for the area based on changing the length and the width. Once I have that model, that's going to allow me to find the maximum by modeling it as a parabola. So I've got a equals 600 minus 2x times x, and now I can expand that into an equation that is a quadratic, or that is a parabola. So again, I'm looking for a maximum. So I want to complete the square to find the vertex. So I'm going to factor out minus 2 from my first two terms. And then I'm going to look for the value that I need to complete the square. So 300 divided by 2 squared is going to be 150 squared. Which is going to give us 22,500. So the value that I need to complete the square is going to be plus 22,500 minus 22,500. And then I can finish completing the square by factoring my perfect square trinomial and then remembering to multiply my last term by whatever I factored out at the beginning. So I'm going to have plus 45,000 here. So now I have a model that represents the area of my pen based on the dimensions of x. My vertex here is 150 and 45,000. My y is the maximum area based on the constraints I've constructed my model from. My x value is when that area occurs. So once I know my x value, I can solve for y. So y is equal to 600 minus 2 times 150. So y is going to equal 300 here. So therefore, the dimensions are x, y, which are 150 and 300. Some examples of how you can use parabolas to model real-world situations to find the maximum